In this video, we are going to look at this word problem that we were not able to get to in class, and it can be a little bit challenging. So take a look. A rectangle is inscribed with its base on the x-axis and its upper corners on the parabola y equals 4 minus x squared. What are the dimensions of the rectangle with the greatest area? So let's look for some key words. So we've got this rectangle is going to be inscribed, which means like set inside. Its base will be on the x-axis, and its upper corners will be, so these upper corners are going to touch the parabola, that is y equals 4 minus x squared. They are looking for the dimensions of this rectangle that will give us the greatest area. First of all, let's see what this even looks like. So here is a graph of the parabola 4 minus x squared. And we've got this rectangle that the base is going to be on the x-axis. So my base is on the x-axis. And the corners, the upper corners, touch the parabola. That's the image that we're going to be working with. And they want us to find the dimensions that will give us the greatest area. So if we're looking for dimensions, that means we're looking for length and width. All right. And we've got to have a variable, and we can only use one variable. I vote that we make, that is terrible. Let me erase that, do a better one. I vote that we make half of the length be x. And because the parabola is symmetric on both sides, we can assume that the rectangle is also symmetric. So that means that this distance will also be x. All right. This is x and this is x. What are we going to put in for our length? Well, we can put in 2x. X plus x gives us our length. Now we've got to figure out how are we going to define our width. We have to define our width in terms of x. And the whole key then is the parabola. So if I plug in an x value, whatever this x value is, and I plug it into my parabola 4 minus x squared, I get out my y value. Say, for example, I plugged in x is equal to 1. Let's just look at an example here. So I've got f of x. This is my function, 4 minus x squared. If I say f of 1, so f of 1, so if I went here, what's going on with my pen here? So if I said I had f of 1, that brought me all the way up here to this. And if I had f of negative 1, that would also come up here. So there could be a rectangle inscribed in our parabola. But we don't know what our x value is. Our x value is just x. So that means if I have f of x, I just plug x into my function. My y value, remember f of x is the same as y, my y value will be 4 minus x squared. So this distance, our width, is going to be 4 minus x squared. So just think, when I plug in my x value, I get out my y value. If I don't have a value for x, my y value is just the whole function. That was the tricky part of this question, was figuring out how you're going to define your variables. The next part is a little more straightforward. We have to remember now that they were looking for the largest area. So area, we know that area equals length times width. So to get the area of our rectangle, we will take our length, 2x, times our width, 4 minus x squared. We'll have to distribute that 2x, so we will have 8x minus 2x cubed. Then you might be thinking, I don't know what's simple about this, and how are we supposed to use this then to figure out where the area will be greatest? Let's take a look at Desmos. So we had 8x minus 2x cubed. All right, well, just think common sense. I've got local extrema here. I've got a local maximum and a local minimum. And we've talked about that before. If I want the maximum for my area, it looks like then I'm focusing in on this point right here. So the x value of this point will be our answer for our x value. So let's look at that actually on Desmos. We can tap, and it says it is 1.155 is the x value for that point. So we found that our x was equal to 1.155. So great, you put in 1.155 and my open math goes, wrong. You're like, that's what was Desmos said. Why is 1.155 not correct? Look back to how you defined your dimensions. Remember, x was only part of our length. To get our full length, we would have to take 2 times our x value to get our length, and we have to take 4 minus our x value squared to get our width. And I have forgotten my calculator at home, so let's just look here on Desmos, and let's see, I wonder if I can just do it on this. Let's see, so if I had 2 times 1.155, oh, okay, good, that works. That's 2.31. So my width, or my length, is 2.31, And then if I take 4 minus 1.155 squared, I get 2.6659. Let's round it to 2 places, 2.67. So we end up with our length of 2.31 and our width was 2.67. I hope this video helps you complete that problem on the homework. And this has been another video brought to you by our sponsor today. We don't have a sponsor. I don't know who would sponsor this. All right, have a good rest of your day.